Hi, I'm Mike Yawn, a Senior Cloud Solutions Architect with Hazelcast. Earlier this year, we launched Hazelcast Cloud Enterprise, our managed service offering for Hazelcast's in-memory data grid. Today, I wanted to give a update on several new Cloud Enterprise features, most notably support for Microsoft Azure as a cloud provider. The place to get started with our managed cloud offering is on the product page shown here. You can get to this page by going to hazelcast.com, mousing over Products and Services, and selecting Hazelcast Cloud. Here you can read up on all of the features and benefits of the service, and then when you're ready to dive in, the sign up is directly on this page. As you see, we have multiple options here. Hazelcast Cloud Starter is perfect for development and experimentation. It's a multi-tenant, pay-as-you-go service with a free tier that provides up to a 200 megabyte cluster. Hazelcast Enterprise is our focus today, and that is a single tenant service that includes higher capacities and enhanced features in areas like security and disaster recovery. To get started with the enterprise product, you just need to provide an email address here, and then someone from our sales team will follow up with you to get your account set up. If you've completed the sign up process, you'll be emailed an invite link, which brings you to the Cloud Console. Whether you've chosen the Starter Edition or the Enterprise Edition, the initial screen is much the same. If you're a Starter customer, you won't have this slider at the upper right that allows you to manage enterprise clusters. As you can see, I already have a couple of clusters running. These are both on AWS. So now let's start up a cluster on Azure. I can click on the New Cluster button. I can give a name to my cluster. I select the cloud provider. AWS has been available for a while. Azure is available now, and Google will be coming a little later this year. I select the region where I want my cluster to be deployed. It makes sense to go somewhere geographically close to your location. And then the instance type I want to run. Since this is just a demo, I'm going to go for the smallest available hardware here. How many instances I want to deploy in each zone. Again, since it's just a demo, one instance per zone will be sufficient. And then I pick which of the available zones I want to use. I'll put this in zone 1. Then the version of the Hazelcast software to deploy, the latest version is 4.0. I can select the address range for my virtual private cloud. Usually the default is sufficient here. You do need to make sure that this address range doesn't conflict with resources that you may already have deployed in the same cloud. So that would be one reason why you might want to go in and change that. The total memory is based on the instance type that we selected. Most of our data will actually be stored off heap in native memory, but we need some Java heap for operations. So this default configuration is generally sufficient. And then we have a couple of options here. I can enable backups, which means we'll get periodic snapshots of the data in our cluster. We will turn on encryption, so all the traffic to and from the cluster will be encrypted. And then public access is a fairly new option, and this actually makes it faster for us to get started because I'll be able to access the cluster directly from my laptop or development workstation rather than having to deploy my cloud clients into the cloud. And then the final option I have here is to do some custom configuration. I don't actually need anything here, but if I wanted, I could go in and, for example, I might want to have indexes on some of my map structures to make queries perform better. Or if I'm using this as a cache, then I might want to configure an eviction policy or time to live to help manage the cache size. In this case, though, all of the defaults are fine, so I am just going to create the cluster with the settings that we've given it. Now, this takes a while to complete. It might be typically 20 to 30 minutes. for it actually to configure the system, deploy the software, and be in a running state. So we will resume recording once this cluster is up and running. A new cluster started up on Microsoft Azure. I previously started a demo cluster on AWS, and both of these clusters are empty. We can scroll down on the Cloud Console here, see that our used memory is 0 and that we have no maps. I can flip over to the AWS cluster that I created earlier and see the same thing. And the reason for pointing that out is I'm going to configure WAN replication between these two clusters so that when we start up our client, anything that we write into this cluster is going to get replicated into the other. So we set that up under this manage cluster area and in settings. Just briefly to go through the kind of things you can set here on settings, we can scale this cluster up or down as needed. We can change the software version. We can configure a logging integration with either Elk or Splunk logging system. We can create a VNet peering for more secure access. We can set up IP whitelists so that our public access isn't open to anyone on the internet. And then finally, the one we're interested in, we want to set up a WAN replication. So there's nothing configured. We're going to go in and create a new one. This is going to be our source, the current cluster. Now we can do this as either active bidirectional replication or active passive unidirectional replication. And we can also configure kind of our batch sizes and capacity. This is essentially a trade-off between how closely the clusters are in sync to each other. And of course, the more tightly you synchronize them together, the more that's going to have an impact on network bandwidth. We can go down to a batch size as small as 1 if we wanted every single write to get replicated immediately, but that's generally not as efficient as batching up our writes into larger groups. So now we go over, this is set up, perfectly. So we will go over, actually, that's not the one I want to replicate to. I want to replicate to the AWS demo cluster. And we're going to make this side passive, which means there's nothing else to configure. And we can save that configuration. And now we have WAN replication ready to go between our two clusters. There's one more thing I want to configure here before we start up our client, and that is I would like to enable Management Center so that we can have a more fine-grained view of what is happening inside the cluster once it starts receiving data. So I can open up that tab and we can see our cluster is active. We have just a single member. And again, there's no data, no maps, queues, topics. There's nothing created yet in the cluster. So that cluster is ready to go, and all we have to do now is to create a client to send data into it. So to create our client, we switch back to the Cloud Console and select the Configure Clients option. We see here at the top, we can choose whether we want public or VNet access. Now, we never configured a VNet peering for this cluster, so we can't actually change the selection. So our clients will use the public access option. We can then select what language our client's going to be in. I'm going to stay with Java here. And the code has already been generated for us, so all we need to do is to download that. We can see that it downloads to the location where I've set up downloads to go. I actually want to copy this out of my downloads directory and into a more reasonable location. And then I can unzip that file. Let's actually change this into a little bit easier view. And I have a terminal window open here where we can see that this has now been downloaded and unzipped. And let me get I could, type this from memory, but that was the wrong window. Here's what I wanted. Yeah, this command right here is actually what will build the client software for us. And so I can just paste that here and it will start to build this. And the client, again, when you see this right here, that shows we've connected to a cluster that has a single member. And we see that data is already being written into the cluster. So let's go back, look again at our cluster. Don't need that anymore. And previously there were no maps here, but now we can see that we have created a map and we can see that the entry count is starting to go up as data is being written to the cluster. Now remember we set up WAN replication, so now we can flip over to our AWS side, which had no data in it, and see that it is similarly getting data written into it as the client software continues to run. If we switch back over to our client window, we can see it's written about 1,200 entries here. I can just stop this now. It'll run as long as we let it continue. And if we look over at the, actually let's look at the dashboard view, click down into this map, and we see that our map at the time we stopped the client had written 1,221 entries. We can look at the same thing on the AWS side and see that it also has 1,221 entries. So WAN replication worked as we wanted. Everything that we wrote to the Azure client was replicated and stored into the AWS client. Take a quick look at the generated source code before we wrap up here today. This is the client source code that was generated for us and that we downloaded and just ran. Most of the code here is setting up the connection to the cluster. This may look a little different depending on exactly what options you selected. So for example, if you did not enable encryption, then the code for the key store and the trust store will not be needed and will not be generated. What will always be generated is the cluster name as set. There will be a discovery token, which is how we find your specific cluster out of all the other clusters out there. The key store and trust store password, again, only if you've turned on SSL. And the cluster group password we don't actually use for version 4.0 of the software, but if you're using Hazelcast 3.12, then you would see that version in the configuration as well. And then once we're configured, we just create a client instance, connect, and then we just start writing random values into the map. And periodically, we write out the current map size, which you may recall seeing in the console when we ran our code earlier. So I just thought it was good to take a look at that code before we're done. Just to wrap up for the day, the focus today wasn't on showing all the features of Hazelcast Cloud Enterprise, but to focus on relatively new releases, software features that have been added since the launch earlier this year. So the biggest of those new features is that we can now deploy to Microsoft Azure as well as to Amazon AWS. We also saw WAN replication and how easy to set that up. In our case, we did multi-cloud, cross-cloud replication, but you can also use that within the same cloud provider to do a cross-zone or cross-region replication. And we also showed that public access allowed us to get up and running quickly because we didn't have to deploy any EC2 instances or Azure virtual machines to deploy our client software. I was able to deploy directly here from my development laptop. That's all we have for today. Hope that was useful. And I'm Mike at hazelcast.com if you have any questions. Thank you.